Welcome to the UGC lecture series. This is the EPG Pathashala. Here we are talking about the course data structures, and this is the second module of the course where we will be talking about list and list ADT. So, as basic data structures course you would have seen list, but here we are looking at a list ADT and we are looking at the different operations associated with lists. We will be looking at what is data structures, the list data structures, and how you can define or specify different list ADTs. So, the learning objectives of this module are to describe the lists and their uses, to understand list ADTs, to know about the different operations associated with list ADTs, to understand the different types of lists, that is it essentially means different list ADTs, and we will be talking about ordered, unordered and index lists. So, first of all, before we go further, let us just look at where all you use lists. We use lists in an everyday life. Today we use it much more in a more sophisticated manner by having it on our mobile, but even from before we used to have a grocery list, we give it, we take it, and then jobs to do list of assignments to be done, some dean's list of students who have been selected or being punished by the dean. So, there are a lot of lists, you can name some other lists also. Lists are used every day in our life. So, a list consists of some sequential order of elements. So, what is the properties of lists? So, can list have a single element? Yes. Can list have no elements? Yes. Can there be list of lists? Yes, all are allowed. So, we will look as now we have to look at the list as an abstract data type, that is what this module is about. Now, when we look at that, there are some properties associated with any list ADT, and that is it has to be homogeneous, it is of finite length and it has a sequence of elements. So, it is homogeneous, that is all the elements of the list are of the same type, it has a finite length. It can have any length, but it is finite, and there is some sequence associated with the elements. So, that is the definition of list. So, consider a room with 40 seats in fixed positions, desks are wasted if there is less than 40 people, and if you have more than 40 people there are not enough desks, that is a typical list. So, an array is like a room, each desk in the is an array location. So, if you look at this picture, this is a room of people in fixed position. So, this is a typical array, and suppose we have some persons in the room who are ordered alphabetically. So, we want to add a new, we want to maintain the list in alphabetic order. It is not necessary that all lists are in alphabetic order, here we are assuming it like that. Now, if you want to insert someone, you have to shift some people. So, if you want to remove someone also, you have to shift. For example, you have Ram, Tim, and now Shiva wants to come and sit in this list, then he has to ask Tim to move back one position. So, seating a new person between two existing people, at least one person must make a move according to the alphabetic order. Now, let us look at the ADT list. Except for the first and last items, each item has a unique predecessor and a unique successor. That means, there is a sequence associated. So, when I am standing in the middle of a list, there will be someone in front of me, unique person, there will be someone behind me, again a unique person. Of course, the head or the front, both terms are used. Head or front of the list will not have a predecessor, and the tail, both are used again, tail or end of the list will not have a successor. We are here talking about linear list. So, this linear list contains element 1, 2, 3, 4, and this linear list is a list in which each element has a unique successor. So, element 1 has a successor 2, 2 has a successor 3, 3 has a successor 4. We are not talking anything about the properties of how it is coming in sequence, that we will be talking about later. Now, before we go on, there are some categories associated with linear list. We are talking only about linear list. There are two categories essentially, that is general list and restricted list. You can have general list and restricted list. Now, general list means you can add anywhere, you can delete anywhere, that is the meaning of general list. But in general list there are two categories, one is unordered, that is the elements in the list are unordered, or ordered, the elements in the list are ordered. So, data can be inserted and deleted anywhere, that is the idea of a general list. Then you have what is called a restricted list. In a restricted list there is a restriction on where you can add and where you can delete. So, you have obviously the first one is queue, first in first out, you would have heard of this, and stack, which is last in first out. So, here data can be inserted and deleted only at some points, that is the ends of the data structure, either front or back. We will that is the restriction. So, this is one way in which you can categorize linear lists. So, when we look at this, when we begin the discussion of a basic list operation, you talk about 4 operations that you generally have: insertion, deletion, retrieval, traversal. These are 4 operations that you can talk of in any list. So, in fact, in any data structure. So, the basic list operations are: construct an empty list, you have to create an empty list, this is a basic operation. Determine whether a list is empty, that is another operation. Determine the number of items in a list, that is another operation. Insert and delete an element or an item into the list. So, these are some of the operations: construct an empty list, determine whether the list is empty, find the number of elements in the list, add or insert an element into the list, and continuing, delete and remove an element or an item from the list. So, you can delete in different ways. You can remove an item given the position, or you can remove all the items from a list also. You can also retrieve an item from a given position in the list. With what is the difference between retrieval and deletion? Retrieval, you will just get the item, you will not delete it. The other one is traversing. Traversing means you can go to each and every element in the list and get its value. You can modify, output, search for a specific value. So, there are different ways. You can modify a particular value, you can output a particular value, you can search for a specific value, you can copy or save a particular value, you can rearrange some values. All this comes under traversal. This is we are looking at it from a very abstract way. Some of these operations, most of these operations are common irrespective of the data type you have, but how that is implemented is what is different. So, construct an empty list, determine whether the list is empty, this is a Boolean operation obviously, determine the number of items in a list, it will give the number. So, the output will be an integer, insert an element, I will come to that, that is a little more interesting. Delete, so deletion, you can delete one element at a particular position, or you can delete the whole, all the elements of the list. Retrieve means you can retrieve from a given position, or you can traverse a list. The traversal is necessary for modifications, for outputting, for searching, for copying and so on. So, now let us go to the list ADT again. The list ADT models this sequence that we were talking about, sequence of position, storing arbitrary objects. Now, remember it had to be homogeneous objects, but it can be arbitrary, that means it can be complex objects also. And when you put it in a list, you obviously have a before and after relation between the elements, between the position, that is implicitly there. So, if you put 5, 9 and 6 in a list, it means 5 comes before 9, 9 comes before 6. I purposely did not put it in order. So, the list of size n is normally represented as A0, A1 to An minus 1, and each element Ak has a unique position k in the list. So, please note, as I told you before, the elements can be arbitrarily complex. Now, when you take the list ADT and the operations associated with it, again as we told you, we are just reforming that whatever the operation we said. So, it can be size, you can find out is empty, you can insert x at a kth position, you can remove something from the kth position. When you just put remove k, it means the item is not returned. You can even have a remove with an item. You can find x, some particular data value, you can find the kth element in a list, you can print the list. So, print list will print the whole list, make empty will create an empty list. So, for example, suppose it is given locate the position of object in the list. So, let us assume I have given the list here, and if it is given find 52. Now, this you can assume is 0, 1, 2, 3, 4, 5, or you can repeat it as 1, 2, 3. Here the assumption, this you have to understand this assumption. So, here 52 the position is given as 3. So, insert an object to a list. So, we want to insert the element x to the list. So, 0, 1, 2 you are putting it in the third position, not the third position, the 0th position, first position, second position, third position. Remove 52, 52 is removed. Find the kth, retrieve the element at the certain position. So, that also you can give. Now, designing a list ADT involves deciding what are the operations that you want to associate with a particular list ADT. Remember, when we were talking about these things, we had said that when you talk about an ADT, that ADT is also associated with a list of operations. If you one ADT with x some list of operations, another ADT with a different list of operations are two different ADTs. This you must remember. So, but this we are talking generally. So, should at least have the following members: constructor, these are called constructor function, is empty, insert, delete, display. Then implementation, what is the implementation of the list ADT involved? We defining the data members and defining function members from the design phase. Remember that list ADT having a different set of operations, as I already told you, is a different ADT. So, what are the accessor methods, accessing, getting access to it? All will return type position. So, first find the first element, it will return the that, last element, previous, next. So, this all will return type. Then designing a list ADT, the update methods are replace the element E with the element E, whatever is in position P. It is how you define it. So, that you have to design it appropriately, and you have to give a definition of that operation also. So, whether E comes first, P comes next, all that you have to give in your definition. Remove the element at the Pth position, insert some element E before P, insert some element E at the after the position P, insert E as the first element, insert last at the first E as the last element. All these are methods. Now, one ADT list need not have all these elements, it depends now. How do you decide? This ADT has to have this operations. How do you decide that? That is decided by what you are going to use this ADT for. Okay. So, for the list ADT I can have 5 list ADTs with different sets of operations, and as a programmer I will decide which operation I want to be, which set list I want to use. Now, is that, can I use anything randomly? It is not that. The list ADT's implementation has to be decided based on what operations that list ADT supports and what operations will be used most commonly. All ADTs will support, that is not, all implementation will support, that is not an issue at all. But then what is most frequently done? Based on that I have to select the implementation. Now, the position ADT models the notion of a place within the data structure where a single object is stored. So, associated with the list ADT we have something called a position. What is this position? A position is a place within the data structure where a single item is stored. So, it gives a unified view of diverse ways of storing a data. It can be a cell of an array, it can be a node of a linked list. So, independent of the implementation, I can say the position is the place where a single element of a particular data structure is stored, not list necessarily. So, element returns element stored at a particular position. So, suppose the elements of a list are 34, 12, 52, we have seen this. Just to tell you again, find 52, it will give a position as output, insert 20 in position 3, it will insert 20 in position 3, here we are assuming 0, 1, 2, 3, delete 52, it will delete 52, find the kth 2, that is at position 2, it will give 20. So, the ADT list is looked as a wall. This wall is nothing about nothing but the information hiding aspect of it. So, here you have a wall between the function display list and the implementation of the ADT. So, here you have the wall and here you want to retrieve something at position, some particular position, the output will be a data item. So, as far as the user is concerned, only this is known. What is inside this is the implementation. What is the implementation is not known, whether we implemented using an array, whether we implemented using a linked list, whether we implemented using a circular linked list, this is not known to the user of display list. Before we go further, we will be now talking about 3 different types of lists. We are going to talk about 3 different types of lists: ordered lists, unordered lists and index list. Okay. So, each of this will be called a ADT, a different ADT, because the operations that it supports or the definitions of the operations that it supports are different. When I say insert into an ordered list, it means different, insert into an unordered list means differently, insert into an index list means it is different. And what you use this list for are also different, the application that you use which uses these lists are also different. So, operation common to all list type, whether it is ordered, unordered or indexed, include removing elements in various ways, checking the status of the list, it is empty or checking the size, iterating through the elements of the list. This is a very common operation that you require as far as list is concerned, going after one after the other. So, the key differences between the list types involve the way elements are added, that is where it is different. So, how are elements added to an ordered list, to an unordered list or to an indexed list, that is where we have the difference. Now, let us look at some common operations on lists. Remove first, this will remove, I have specifically not put the parameters. When we define a ADT, we have to put the parameters and we have to say what those parameters mean. Okay. That is how you define, that is the comments that you have to give when you define an ADT. So, this is, we are not talking about the ADT, we are just talking about common operations on list. So, remove first removes the first element from the list, remove last will remove the last element from the list, remove just remove gives a removes a particular element, that is if you say 20 it will remove the element 20 it will remove. First we will examine the first, what is the first element in the list, last we will examine what is the last element in the list, and contains determines if a particular element is in the list at all, contained in the list. It will check whether is empty, will check whether the list is empty. Size will find out what are the number of elements in the list. Iterator will return an returns an iterator for the list's elements. ToString returns a string representation of the list. So, these are common elements. If you look at these, the three removes are about removing or deletion. First and last is about accessing. This is checking whether a particular element, searching for a particular element in the list. Is empty and size are typical operations, whether the list is empty, what is the size. The other two are specific to certain implementation. Now, again as we defined, a list is a linear collection like a stack or queue, but it is more flexible because elements can be added or deleted from any position anywhere in the list. So, as we already told you, we are trying to look at three different types of lists: ordered lists, unordered lists and indexed lists. So, what is ordered list? Ordered list, its elements are ordered by some inherent characteristic of the elements. So, it can be ordered alphabetically, it can be ordered numerically, it can be ordered according to the pay scale or something, mostly ascending, descending, numerically, alphabetically, names in alphabetic order or numeric scores in ascending, descending, it can be ascending or descending. So, the elements themselves determine where they are stored in the list. Now, what is special about ordered list? Where in the list it has to be stored is dependent upon the value of the element. So, what is special operation that is particular to ordered list is you just say add. Remember, as we discussed before, the add is the operation where it is different, the add operation is different for ordered, unordered and indexed list. So, in add it adds an element to the list. So, you will have to specify where you want to add and it will add it. It will add an element to the list, the correct place is specified by the value of the element, that is the ordered list. So, for example, insertion a general linear list with ordered data. So, you have 10, 20, 30 and you have been asked to add 25. You do not have to talk about the position at all, it will automatically be added only here. How this is done I am not telling here. Here we are defining that in that ADT of a sorted list. So, this is what will happen when you say insert 25. So, the ADT sorted list maintains items in a sorted order and inserts and deletes items by their values, the element values and not by their positions at all. So, for example, if you want to add 58, this is the only place where 58 can be added. New values must be inserted so that the ordering of the list is maintained. So, when you are implementing it, you have to see that the addition maintains the order of the elements. That is what an implementer of an ordered list ADT has to do. So, list search is normally used to find or locate data in a list. To insert data, we need to know the logical predecessor to the new data. Okay, suppose I want to add one data, I need to know the previous node. To delete data also, we need to find the node to be deleted and only then we can delete it, and you have to identify its logical predecessor. So, to retrieve a data also we need to search the list and find the data. What are we talking about here? We are talking about the need for list search. So, list search is needed in three places: for insertion, for deletion and for retrieval. For insertion, it is needed to know where I need to add this new element, I need to know the address of the predecessor. For deletion also I need to find the node that has to be deleted, for that also I need to know the address of the predecessor. Predecessor, we remember we have said that each element will have a unique unique predecessor and successor, and to retrieve a data you need to go and find the data. So, this is where list search comes into the picture. So, for list search we have to use a sequential search because there is no physical relationship among the nodes. The classical sequential search will return the location of the element when it is found. The address of the last element is not found, but for our purposes, because the list is ordered, we need to return the address of the element where it is found as well as the location of the element when it is not found. So, basically in list search what it will do, it will find the location of the element, and if it is not found, it will it should be placed there, or it should say that it is not found. So, let us see how we can retrieve from a linear list. So, I have this. Now, I want to retrieve this data. So, here when I retrieve the data, this retrieve data is given. So, next you have the first Boolean first, that means it will return the first element, there is no precondition. Now, post condition is if the list is empty, nothing will be returned, otherwise the variable element contains the first element in L and next item to be returned is the second in L if you are defining text. So, this will return a true value only if there is at least one element in the list. If there is no element in the list, it will not return a true value. So, you can define it as Boolean, it need not necessarily be defined as Boolean. So, this next is similar, the precondition is the first operation has to be called at least once, only then you can call the next. This is one way of implementing it. The variable element contains the element that is next in L if there is one, if there is not one, then it will not return. So, if there is more than one element only, it will be true. This list traversal is again a very important operation, the process of accessing each and every element in the list. It can be defined in in terms of two other operations. You can access the first element in the list, you can access the next element in the list, and you can keep on traversing, or we need what is called a walking pointer that moves from node to node unless you find the particular list. So, this is the way. Traverse an operation in which all elements of the list are processed sequentially one by one. So, you will first go here, next you will go here, and next you will go here. So, this is the way it is done. Unordered list, the order of the elements in the list is, so we have till now looked at ordered list. So, remember what is the property of the ordered list? The ordered list is the place where the element is stored is determined by the element's value. Okay. So, all operations you have to define that way. Here we are not looking at the implementation, we are just looking at how it is done. Now, unordered list, the order of the elements on the list is not based on a characteristic of the element that is stored, but is determined by the user. For a new element can be put anywhere in front of the list, in the rear of the list, or on a particular or after a particular element already stored in the list. So, a shopping list, to do list, here there is no ordering. Okay, you just have a list, you can put it anywhere you want. So, remember we had a set of operations that are true for all lists, then we had a set of an add operation specified for ordered list. Here we have three operations that are specified only for unordered list. Add to front, you can add an element to the front. There you cannot add an element to the front, because the addition you can just add whatever element you are adding for ordered list, it will come and be put in the correct position. But here in unordered list you can add anywhere. So, you can add to the front of a list, you can add to the rear of a list, or you can add after a particular element in a list. So, I want to add after 20, you can do that. So, the next is index list. Now, what is this index list? Lists are referenced by the numerical position in the list, and which is called as index. So, there are three lists we were talking about: ordered list, unordered list, and index list. Ordered list, the elements come because of the value of their element. So, if it is ascending one order and descending another order. Second was unordered list, the elements are just there, user can say where he wants to place what. Next is the position. Now, here the elements are referenced not by the numerical value, not determined by their values, but by the position in the list, and that is called as index. It is the position in the list that is important, and the user can determine the order the items go into the list. Every time the list changes, the position of the element will also change. Okay. So, current first place holder in a race. So, if you have a list and you have a current first place holder in the list, then his position will keep on changing depending upon how the list changes. So, for example, operations that are particular to index lists are add an element at a particular index in the list. So, you have to give the position where you want to add. Remember, the first you just gave an element and it was put in its correct position. In the second unordered list we gave, you have to put it after 1, you have to put it after 2, or you have to after last, or you have to put it after a particular element. Here you have to say the index, add an element at a particular index, set the element at a particular index to a particular value, get the reference to the element at a specified index, get the reference, returns the index of a specific, this element is given, what is its index, removes and returns an element at a particular index. So, these are operations that are specific to index lists, and we talk about this ordered, unordered and index lists. Now, the idea here is that when you talk about ordered lists, you have a particular implementation. When you talk about index list, you have some other implementation. When you talk about ordered list, you have an implementation. The operations that you want, you had a list of common operations, isn't it? Some of those operations you will come and put here. For example, in this particular index list operation, you do not have to have all these operations, it depends on your application. That is the way we say it, but actually speaking, in effectively you should have a library of ADTs defined, and the user of the application should use these ADTs and get it and use those ADTs depending on the preconditions and the post conditions. So, for example, in one particular operation you can have add, set and remove alone, you need not have get an index of. It is not that just because I have an index list, I should have all the operations associated with the index list in the ADT list, that is not at all specified. What we need to have is only the operations that we want to define on this index list. Now, depending on the operations, as I have been telling you again and again, the implementation will be chosen appropriately. It also depends on how frequently some of these operations are used. So, when we are going into the next module, we will be talking about different types of implementation of lists and how those implementation is decided by the design of the ADT, that means what is the ADT and what are its operations, and also by how frequently these operations are used. So, depending upon that, the implementation also will change. If you are using some operations very frequently, then those operations has to be efficient. So, you will choose an implementation according to. So, what did we do in this? We took a list and we tried to look at all possible operations on list. We looked at first what is the concept of list, then all the different operations that can be carried out by on the list. We looked at some common operations that can be done on any ADT. Then we looked at some common operations can be looked at lists, all types of lists. Here we looked at 3 types of lists: ordered list, unordered list, and we looked at index list. So, we looked at all those and we looked at all the operations that are possible specific to each of these different types of lists. So, this is in this module, this is what we have discussed. In the next module, we will be talking about different types of implementation for the different types of lists. So, that is what we will be talking about. Thank you.